Hello. Hopefully, this is all going to go better this time. I only have a few minutes, so I can't go into the detail that I had gone into before, um, but I would still love to talk through some of the key points in the next 10 minutes that I have before my next meeting starts. So let me just go ahead and slightly make some screen adjustments since you are here, and we'll go from there. So I'm just opening this into a new tab, and it should be good to go. Okay, so what I'm going to have open on my side is the document, the data sheet, and uh, the questions. So let me just really quick post an update on that announcement that I do have it good to go now, so that anybody else can join. Okay. So let me start by sharing my screen so you can see the documents that I have. And like I said, I have a few minutes, but what I want to focus on are the points that most students struggled with. And most questions that I've got don't pertain to part one or part two. However, if you're struggling to measure the boulevard bend, the meander is the part that is the whole loop. So for question 6A that you see here, excuse me, 6B, where it says to measure the whole bend. The bend is actually going to be, hopefully it zooms in, perfect. The bend is going to be if you measure all the way like this in purple. So that's what you're actually measuring for the distance for part 6B. And then when you do part seven, question seven, excuse me, and it has you measure the distance through the call cutoff, that's actually this part here. So those should be two different measurements. And hopefully you saw that the first purple line that I drew, much longer than the second one. Okay, so that is one of the other questions that I do get quite often on this activity. Otherwise, most students have had hangups or confusion on this part of the activity. And so when you get to this part of the activity, there are specific steps, step one, step two, step three, and then sometimes steps within a step. But the point being is that I used to have two students look at two different data sets from two different streams or rivers. Now you're only looking at Mercer Creek, but if you'll look in my data sheet, which you can see it, I have made a copy and named it demo copy. You should also make a copy for yourself. Um, but there is Mercer Creek dataset 1 and Mercer Creek dataset 2, both within this document. You need to analyze and manipulate, I guess, the data that is in dataset 1 and dataset 2 for Mercer Creek. Those are your two datasets, but it's for the same creek. So once you open that, you've already begun with step one. So step one is actually opening these data sets, and then you will start to rank them. That's step two. So for ranking your peak annual flood discharge, you're going to look at the far right column here. This is your peak flood discharge for data set 1, and I'm not going to talk about data set 2 because you're going to be responsible for it, and I'd like you to do that one. So I don't want to give you too many answers as you work through. So what you're going to start with is here it says rank, and you're going to rank them as it describes with the largest flood discharge value as 1, and then each subsequently smaller flood discharge with the next number. So I'm going to do this really quickly, and then maybe you can compare your values to mine and see if you got anything different. I believe, oh, I missed one. There we go. 9, and 11. So I've ranked those based on the values from highest to lowest. And now I can move on to step 3, where it says to determine the or calculate the recurrence interval using this equation. So N is actually the number of record years, and you can actually count 1, 2, 3, how many years of data you have. For that, I'm going to show you a shortcut so you can figure out how many records if you don't want to count it that way. But that's going to be your N value. So if you look at the example, there's some imaginary river and it has recorded flood years 1990, 91, 92, 93, 94, and 95. You'll notice that that is 6 records, even though the difference between those years is 5. That's because we count each year as its own individual record, or sometimes we call those hydrologic years. So if you want, you can count each one of these records from 1957 to 1967, or you can highlight all of them. So I just clicked and dragged through. And you'll see in the bottom right corner, there is a green button that appears. So if I unhighlight, that green button is gone. So I'll do it again, and it appears. And if I click it, in there is an option to select count. Now it is telling me it has counted 11 here. That also tells us we have 11 water years. So to calculate the recurrence interval then in Google Sheets, which I'm very comfortable with, you can do it with a calculator if you want. You always start with an equal sign. I'll put my parentheses because I'm going to follow my equation. It is 11 plus 1, close my parentheses, divided by M, which was the rank that you already did. So you can type in the rank for that line, or you can just click that cell and hit enter, and it will calculate the recurrence interval for you. And when you do it on Google Sheets, it will suggest an autofill. And so I'm going to do autofill, and it did all of the calculations for me, which is very quick compared to putting it all in a calculator one by one. So now that I have my recurrence interval, I can actually manipulate this data in a way to set it up so that I can have a flood frequency graph. So really quickly, because I'm running out of time here, the way we do that is to highlight all of the data in that data set, except for the gray bars. Once you've got it highlighted here, you're going to go to Data, Sort Range, and Advanced Ranged Sorting Options. Click Data has a head row, and now Sort By, you can choose Rank. Click Rank, leave this alone, we like it the way it is, and click Sort. It is now sorted by rank from 1 to 11, so from the highest to the lowest rank. And all of my discharge values also are in line, so I know that I didn't make a mistake there. Since I've done that, I can now look at my data in a different way, which is in a graph. So at the bottom, it says data sets. Instead of looking at the data set, now you're going to click where it says flood frequency graph. I've preset it up to have a graph made for you. And we haven't done anything with data set 2. You'll do that. But for data set 1, you can now look at each of these recurrence intervals, 5, 10, 50, 100, 500, and determine what the peak annual flood discharge would be in cubic feet per second for each of these years. So at 5, I'd go up and see where it intersects that blue line. I'd come across and I get about 250 cubic feet per second for the 5-year recurrence interval. And you'll complete your data table with all of that wonderful information. Hopefully that's the part that was most sticky or confusing for students. And my hope is that even just in the quick video that I've been able to clear up some of the questions you have. You still have to do data set 2. I just didn't want to do it because I wanted you to have a chance to still manipulate that data and report it in your work packet. If you need me to pop on and do another video for other parts of the lab activity, please don't hesitate to comment. I just can't do it till after 6:30 tonight because I'm already about a minute late for my next meeting. Okay, I hope that helped a little bit. And if you need more guidance, just go ahead and, like I said, comment on that announcement, and I'll try to make another video later. Have a good night.